I'll be talking to you about building AI search for your web apps. I'm Daniel Phiri. I do developer experience and developer relations at Weaviate. I build software, I produce music, and I write prose some places on the internet. Um, I want to start out by saying, please stay. I'm begging. I know this is another AI talk, and you're probably super tired of hearing about AI, but I promise this one is really informative and could be used in stuff that you work on every day. So please stay. Anyway, so we'll be talking about building AI search in your web apps. AI, the subset of AI we'll be talking about being machine learning, and that galaxy is way too big to explore. There's way too many topics to get into in this 10-minute talk at least. And I want to start with something that we use every day as promised in my previous slide, that thing being search. Search is in everything that we do on the internet at least, whether it's looking for music, movies, or that 3 a.m. Wikipedia search, we search everywhere. The problem with search, however, is sometimes it just works and it leaves us banging our heads with the wrong queries, spending countless hours tweaking queries to look for something that should have been much easier to find because we don't use the right search. Now, what is the search that most people use today? Traditional search. And that comes with its fair share of challenges. When I search something like, why do airplanes fly? Because I'm super curious, I get a response like, why you should fly with expensive airplanes. The ad experience is basically people's experience searching. Not a fan. Anyway, what this does, first of all, is it doesn't answer our question. And two, it's a keyword match, which means it looks at the query and looks at your data set and then just matches and looks for whatever matches the most keywords in your query and then returns it to you. But it doesn't answer your question. And as a user, it's a really terrible experience. You don't really want that. And so I want to introduce to you something that makes it better. And this is the AI portion of our talk. This is called semantic search or vector search. And what this does is it actually captures the meaning. And I'll demonstrate why. So when I do search something like, why do airplanes fly? It looks in my data set for something that matches the meaning of the query. In our case, this would be something like an article from NASA, Dynamics of Flight, and it actually explains that airplane wings are shaped in a special way that helps them move up in the air and make the airplane body fly. And this is exactly what we want. This is how search should be. And everyone, at least after knowing now, should want to use search or should want to do and search semantically. Let's get into how this actually works. I did mention machine learning models are behind it. So what we do is we get our data, pass it into a machine learning model, and then importantly, generate vector embeddings. These vector embeddings are the backbone of a tool or a technology like semantic search. What we do is we get our data set and we pass that through a machine learning model or a vectorizer, and that generates vector embeddings. In our case, we have the article about expensive air's modern fleet. We pass that in our machine learning model, vector embeddings. We do the same thing for our other article, the NASA article. We pass that through our machine learning model, vector embeddings. And these are sort of like semantic representations of the data using machine learning algorithms. And what this does then is plot that data into a vector space. Now, to understand the vector space, imagine millions, thousands, hundreds of dimensions all plotted into this space, sort of like you would do with colors in RGB encodings. In this example, what we do is we see similar items next to each other. We see chicken, cat, dog, wolf sort of bunched up together in the same area because they're animals. And so when sort of giving these, so the machine learning model understands this and represents that through vectors, and then when they're plotted, they sort of end up in the same region. It's the same thing for fruits that you see On the other side of the screen, you have banana, apple, sort of bunched together because they have the same meaning. And what this does is, when with respect to our query, when we do search, why do airplanes fly? That we pass that through a machine learning model and get vector embeddings for it. We then get those vector embeddings and then plot them in a vector space. We then use algorithms to search for the nearest object near our plotted vector. In our case, this is the NASA article, and that just happens to be the most relevant answer for our question. Now, because of vectors being a mathematical representation of data, we can abstract that away from just text data, and we can apply that to different types of data, image data, video data, audio data, and that means we have multimodal embeddings. We vectorize this information, and then now we can search through images, audio, text. Let's actually demo what this search looks like. So I have an example here of a keyword search. When I search dogs, I don't really get response. Let's try dog. Right, so I get a couple responses, but I want to search for other animals. And I get some responses, the animals, which works, but I don't really get the responses that had dog in it. And let's look at what is behind that. So to actually get semantic search working in your JavaScript application, the first thing you have to do is import the Weaviate client here, and we import that and then initialize a class object. We give our class a name, we define a vectorizer, we import some data, and then really importantly, we have our query here, our near text query, which near text query function, and in that we're using BM25, which is Weaviate's keyword search. What we want to do is comment that out to actually use semantic search, which is near text. And so now we pass our search query that the user enters as a concept, and then Weaviate does the query. So now we'll save this, go back to our application, refresh, and now when we search animals, we should get, see we have dog there, we have the animals, and then we have other responses which have pet in it. So the query understands that a pet is an animal. So really interesting approach. And we can actually do a generative search where we interact with a large language model and get some fun facts about the songs that we get returned. And so if we say Africa, and then let's see what we get back. Takes some time, but we get a bunch of songs about Africa, all that talk, all are Africa themed. And that's pretty interesting. So on to the next demo. Really quickly, I want to show how multimodal works. And so if I search chirp, we get birds because it understands. So semantic search over multimodal or data that has multiple modalities. We get the bird chirping sound here. And we actually get responses of pictures of birds, which is pretty interesting. And the way that works, similarly, we run a keyword search here with, we run a semantic search with near text over embedded data, and that embedded data happens to be multimodal data, which is text, images, and videos. Really quick to summarize. Let's go back to our slides. Right. Quick demo. What's that got to do with JS? We always build search apps. We're building search apps in a lot of the things that we do, and a lot of the time we have a JS app or a TypeScript app, and we have our data, and then we want to expand that with AI, and what we need for that is a machine learning model or vectorizer to create the vector embeddings that we talked about, which power the semantic search. Your options are something like OpenAI, Cohere, Hugging Face, Gemini by Google. And of course, a vector database to store these embeddings and use the machine learning algorithms to actually do the search that I just demoed. And that's all you need to get into building AI applications. Just to go over it again, JS application, data, machine learning models, and a database sort of tie that all in. And all these machine learning models are accessible through Weaviate modules also. And if that's something that you'd like to know more about, you can check out this link here. You can scan the QR code. You can look at the resources in that page. And that's been me. Thank you so much for listening. You can find me online anywhere, or you can follow us on GitHub or our website. Check out our Slack or our documentation. Thanks again. Take care.